Hello and welcome to TI Precision Labs. In this series, we're going to discuss Embedded USB 2.0 or eUSB2. We will go over the basics of the new eUSB2 supplement to the USB 2.0 specification, where it can be used, and how it is different from regular USB 2.0. The Embedded USB 2 physical layer supplement to the USB 2.0 specification was developed to address the need for a low-voltage USB 2.0 PHY solution. As technology nodes for SoCs in phones, tablets, and laptops scale smaller and smaller, it becomes more difficult to support 3.3-volt I/O cells. eUSB 2 drops signaling levels to 1.2 volts or lower, and provides enhancements to optimize power efficiency. eUSB 2 is capable of supporting USB high-speed, full-speed, and low-speed operation and requires no change to the existing USB 2.0 software programming model. eUSB 2 also uses the same two data line configuration, shown as ED+ and ED- as USB 2.0, shown as D+ and D-. VBus and power delivery are not impacted by eUSB 2. eUSB 2 has two main operational modes, native mode and repeater mode, both shown here for a host SoC. In the most direct form, eUSB 2 can be used to connect two devices on the same board, like the connection shown between the host SoC and the device SoC. This is known as native mode. In this mode, the speed of the connection may be set to a predetermined speed, high speed, full speed, or low speed, or limited to a subset of supported speeds. And while native mode does the job of eliminating the 3.3-volt I/O requirements of USB and allowing for a typical interconnect trace length of 10 inches or more, the main attraction of USB for many engineers is lots of external connector options, 5-meter cable lengths, and the fact that a large interoperability ecosystem is not present. Native mode is a dedicated internal connection that is not compatible with external USB ports. This leads us to eUSB 2 repeater mode. Any SoC that supports eUSB 2 can be paired with an external eUSB 2 repeater to maintain interoperability and backwards compatibility with the full USB ecosystem of host hubs and devices. eUSB 2 repeaters can be configured as host repeaters, device repeaters, or even dual-row device repeaters that swap based on commands from the SoC. The USB interface of the eUSB 2 repeaters can be paired with any of the standard USB connectors and can connect to USB host, hubs, devices, as well as connect to other eUSB 2 repeater-based applications. As always, when a USB 2.0 device is connected to a USB 3.0 host or a USB 3.0 device is connected to a USB 2.0 host, the connection will be at USB 2.0 speeds. So, are eUSB 2 repeaters external level shifting repeaters that allow SoCs to use 1.2 volts or lower voltage I/O cells and be placed 10 inches or more away from the USB connector? Why, yes, they are. Here's a typical USB 2.0 high-speed test packet, along with a eUSB 2 high-speed test packet. As you can see, both USB and eUSB high-speed test packet data content is identical. But if you look at the differential signal amplitude, the eUSB 2 packet is at about half the swing of the USB 2.0 packet. Likewise, if we look at a USB high-speed I diagram and now a eUSB 2 high-speed I diagram, you can see the similarities. Both USB and eUSB high-speed signaling have the same I opening shape with respect to bit timing and slew rate when viewed using the traditional USB 2.0 near-end I compliance mask, but the eUSB 2 has about half the differential amplitude of USB 2.0. What about that stray line bisecting the mask on the eUSB 2i? It is caused by the longer end of the packet width when a test packet is sent through a repeater or a hub. We'll talk about that a bit more when we get into compliance, but it is expected. If you'd like more information on I diagrams and what can impact USB I diagrams, then please check the links at the end of the presentation for more information. So, is eUSB 2 just level-shifted USB 2.0 signaling then? Not exactly. Here you can see the typical 3.3-volt differential signaling of a USB full-speed packet. The D+ and D- lines swing from 0 to 3.3 volts to create the USB differential J and K states, with a single-ended 0 to denote the end of the packet. Next, we'll look at the eUSB2 behavior in full speed mode. In eUSB2, the 3.3 volt differential signaling of USB full speed is translated to 1.2 volts or lower single-ended signaling on the ED- by the eUSB2 repeater, with the end of the packet appearing as plus on the ED+ line. The bit time of 83 nanoseconds remains the same. For a low-speed device, the 3.3 volt differential signaling of USB is conversely replaced with the lower voltage single-ended signaling on ED+, and the end of the packet is seen on ED-. So what else is new in eUSB2? To be able to configure the eUSB2 repeater in the correct mode, handle USB 2.0 high-speed handshaking, and support the USB 2.0 low-power states, the eUSB2 supplement uses N-band signaling in the form of control messages sent from an SoC to an eUSB2 repeater to keep the USB and eUSB2 buses in sync and optimize power. All eUSB2 capable devices, SoC or repeater, are required to support control messages. The cm.fs control message is used to enable low power states. Likewise, cm.l1 and cm.l2 are used to enable even lower power mode support. cm.reset is used as a USB bus reset to help configure the bus or to clear errors. cm.test is used only for compliance mode testing, specifically for eye diagrams. And cm.wrap is used for direct register accesses. So will an end user be able to tell if a product is using eUSB2 or not? No, they won't. In the USB ecosystem, an eUSB2 repeater would count as a USB 2.0 hub tier. In the typical USB 2.0 interoperability test tree used for USB compliance testing shown here, you can see the USB 2.0 specification supports a maximum of 5 hub tiers connected with 5-meter cables. The tree also has a variety of different hubs and devices connected. The devices connected are a blend of high speed, full speed, and low speed, and they support a mix of isochronous and asynchronous traffic to verify system interoperability and backwards compatibility. So in USB 2.0, there are up to 5 tiers of hubs possible. If you have a eUSB2 repeater, that would count as one of those tiers. In the modified interoperability tree shown here, the host implements an eUSB2 repeater, and the tree is simply reduced by one hub tier. All the same device speeds, traffic, and cable lengths remain the same. Likewise, when running USB 2.0 electrical compliance, an eUSB2 repeater would act similar to a hub, with packets having allowable end-of-packet dribble and drop synchronization bits at the beginning of each packet. In summary, eUSB2 is a low-voltage, low-power internal interface for chip-to-chip interconnect, and it can be extended to the popular USB 2.0 interface using repeaters with no visible impact to end users. If you have any questions about eUSB2 or USB, visit our engineer support forums at e2e.ti.com and look for us in the interface section. If you want more information on eye diagrams and what can impact USB eye diagrams, please check out the other presentations in our TIPL series.